بسم الله الرحمن الرحيم. محاضرتنا اليوم موضوع oral surgery هو حول كيفية الدواء. Call it sterilization, disinfection, and antisepsis. These three topics that are related to how we can deal with the instruments for second time after its use for the patient. The term decontamination. What means decontamination? The definition of this term is the process of removal of contaminating pathogenic microorganisms from the articles by process of sterilization or disinfection. It is the use of physical or chemical means to remove, inactivate, or destroy living organisms on a surface so that the organisms are no longer infectious. We can use it for the instruments, for the skin hand, mucosa, or any material that need to use for human being. Any other definition of decontamination, it is any procedure that reduces pathogenic microbes to level where items are safe for handling and disposal. It can be achieved by three ways: by cleaning, disinfection, and sterilization. هذه الطرق الثلاثة هي for decontamination of any material. We start with the cleaning. Cleaning, a process that removes foreign material, dirt, organic matters, must precede disinfection and sterilization. في حالة أنه الكلينيك هي ليست بإزالة كافة الميكروأورجانيزم pathogenic microorganism، فلهذا يجب أن نستعمل وراءها الكلينيك هو disinfection or sterilization, usually done with soap and water or detergent. Other method of cleaning is sanitization. Is the process of chemical or mechanical cleansing applicable in public health system, usually used by food industry. It reduces microbes on eating utensils to safe, acceptable level for public health. Wash, rinse, and sanitize pots, pans, glasses, dishes, and utensils that have cleaning by this method in food health applications. Other term is disinfection. What means disinfection? A process of elimination of most pathogenic microorganisms, excluding bacterial spores, on inanimate objects. The disinfection can be achieved by two ways: physical method and chemical method. The disinfection is not sterilization. It is for killing the microorganisms like bacteria and the spores of bacteria, but the resistant bacteria or viral that cannot be killed by disinfection. The disinfections, the material that used for disinfection is called disinfectants. The disinfectants are chemicals that are used for disinfection. Disinfectant should be used only on inanimate objects. Different disinfectants have different target range. Not all disinfectant can kill all microorganisms. Some methods of disinfection, such as filtration, don't kill bacteria. They separate them out from the objects that need for be disinfected. Disinfection, it is for a liquid, for gas, for a solid object like the stainless steel instrument, and for hand or mouthwash. The last term, sterilization. This term means the process where all living microorganisms, including bacterial spores, are killed. Sterilization can be achieved by three methods: physical, chemical, and physiochemical means. This figure shows the method of sterilization that used in the clinic and in the theater or any part of hospital that have need for sterilization. What mean asepsis? Asepsis is the employment of techniques such as usage of glovage, air filter, ultraviolet rays, etc. to achieve microbes-free environment. Any method for that need to have no any microbes live within the environment is asepsis technique. The antiseptics. What mean antiseptics? Antiseptics defined are mild form of disinfectant that are used externally on living tissue to kill microorganisms. Example, on the surface of skin and mucous membrane. So the antiseptics that used for on living tissue like skin, mucous membrane, or other tissue. Bacteriostasis, or call it bacteriostatics, is a condition where the multiplication of bacteria is inhibited without killing them. That is chemical structure or any method for not kill the microorganism but inhibit it to have no any growth that occur for the microorganism. Bactericidal is that chemical that can kill or inactivate bacteria. Such chemicals may be called variously depending on the spectrum of activity, such as bactericidal for bacteria, virucidal for virus, fungicidal for the fungal, microbicidal for microbes, sporicidal for spores, tuberculocidal for TB, or germicidal for any germs that have used these chemical structures. This figure shows example for bacteriostatic and bactericidal drugs. The example for bacteriostatic like chlorphenicol, erythromycin, clindamycin, sulfonamide, trimethoprim, and tetracycline. But as a bactericidal example, aminoglycosides, beta-lactamase like penicillin and its derivative, vancomycin, quinolones, rifampicin, and metronidazole that have act as bactericidal. Antibiotics. This term, as defined, are substances produced by one microbe that inhibit or kill another microbes. Often the term is used more generally to include synthetic and semi-synthetic antimicrobial agents. So it is antimicrobial agents that have used from taking from the other microbes that will inhibit or kill other microbes. The importance of sterilization and disinfection. First, safety in laboratory. Second, the patient safety depends on using proper method of sterilization to prepare instruments, needle, the IV fluids, intravenous fluids. Third, the accuracy and validity of microbiological tests. The uses of sterilization. For which purpose we use sterilization? Sterilization for surgical procedures like gloves, aprons, surgical instruments, syringe, and etc. are to be sterilized. Sterilization in microbiological work like preparation of culture media, reagents, and equipment where a sterile condition is to be mentioned. The classification of sterilization and disinfectant. You have two classifications the physical agent or chemical agent. Other classifications use physical and chemical and physico-chemical agent, but the main is physical agent that have heat, radiation, and filtration, and we use chemical agents. This figure shows the method of sterilization or disinfection. We have three parts: physical, chemical, physico-chemical. The physical is divided to sunlight, heat, vibration, radiation, and filtration. The heat divided to dry heat and moist heat. The dry heat had red heat, flaming, incineration, hot air oven, infrared. The moist heat below 100 degrees centigrade, at 100 degrees centigrade, and above 100 degrees centigrade. The radiation used either non-ionizing or ionizing. The ionizing either electromagnetic or particulated radiation. The filtration either use earthenware, asbestos, centrated glass membrane. The chemical have two classified, liquid or gases. The liquid chemical, either alcohol, aldehyde, phenols, halogens, heavy metals, surface active agent, and dyes. The gases, formaldehyde, ethylene oxide, and plasma. This is the main method for sterilization and disinfection. We start with the first method is physical methods. First physical method is sunlight. The microbicidal activity of sunlight is mainly due to the presence of ultraviolet rays in it. It is responsible for spontaneous sterilization in natural conditions. In tropical countries, the sunlight is more effective in killing germs due to combination of ultraviolet rays and heat. By killing bacteria suspended in water, sunlight provides a natural method of disinfection of water bodies such as tanks and lakes. Sunlight is not sporicidal, hence it does not sterilize. أشعة الشمس هي من الوسائل الطبيعية التي تعقم، ولكن ليست تعقيم كامل لكل الفيروسات أو إلى السبورات اللي في الطبيعة، ولكنه معقم نظيف وآمن المواد التي تكون مباشرة تحت أشعة الشمس. The second method is sterilization by heat. Heat is considered to be most reliable method for sterilization of articles that can withstand heat. Heat is most effective and a rapid method of sterilization and disinfection. Heat acts by oxidative effect as well as denaturation and coagulation of proteins. Those articles that cannot withstand high temperature can still be sterilized at lower temperature by prolonging the duration of exposure. إذا heat هو يعمل على أكسدة بعدها تحليل وهذه المواد البكتيريا أو الفيروس أو الفنجل، هذا يؤدي إلى قتل أو تحديد نمو الميكرو أورجانيزم. Sterilization by heat divided into methods: dry heat and moist heat. The factors that affecting sterilization by heat are nature of the heat. Moist heat is more effective than dry heat. The temperature and time. Temperature and time are inversely proportional. As the temperature increases, the time taken decrease. مسألة عكسية ما بين الوقت ودرجة الحرارة. كل ما تزداد درجة الحرارة كل ما يقل الوقت. The other factor, number of microorganisms. More the number of microorganisms, higher the temperature or longer the duration required. Other factor, nature of microorganisms, depend on substance and strain of microorganism. Sensitivity to heat may vary. Spores are higher resistant to heat, so need very high temperature or very long time. Type of material that used for surgical purpose. The moist heat is more effective than dry heat or prolonged exposure. Certain heat-sensitive articles must be sterilized at lower temperature. حقيقة تحتاج مواد خاصة سوائل إلى حرارة قليلة لتعقيمها لأنها تتأثر بالحرارة. The presence of organic material. Organic materials such as protein, sugars, oil, and fat increase the time required. How the heat act on for sterilization or disinfection? Dry heat acts by protein denaturation, oxidative damage, and toxic effect of elevated level of electrolytes in absence of water. The moist heat acts by coagulation and denaturation of protein. Moist heat acts by denaturation and coagulation of protein, breakage of DNA strand, and loss of functional integrity of cell membrane. The moist heat is superior to dry heat in action. The temperature required to kill microbes by dry heat is more than the moist heat. نحتاج إلى درجة حرارة في الدراي هيت أكثر من المويست لأن تأثير water that have a high temperature and pressure that need to kill the microorganisms. We term thermal death time. What this term is the minimum time required to kill a suspension of organism at predetermined temperature in a specific environment. That is the thermal death time. وعلى أساس راح نتحدد المايكروأورجانيزم and the death time at a certain temperature. We start by sterilization by dry heat. Dry heat at 160 degrees centigrade holding temperature for 1 hour is required to kill the most resistant spores. The article remains dry. It is unsuitable for clothing which may be spoiled. حقيقة الملابس أو أي قماش قطني صعب أن نسوي sterilization by dry heat لأنه راح تغير اللون مالته وتكون أكثر تلفا من الميتال that used. Other method of sterilization by dry heat is red heat. The articles such as bacteriological loops, thread wires, tip of forceps, and searing spatulas are sterilized by holding them in benzene flame till they become red hot. This is a simple method for effective sterilization of such articles, but is limited to those articles that can be heated to redness in a flame. حقيقة نستعملها في مختبرات الميكروبيولوجي لتعقيم الهيد of instrument خاصة اللوب لنقل الميكروأورجانيزم يجب أن تعقم لحد kill. فلهذا نضعها على دايركت بنزين فليم حتى تكون تحمر وبعدها يجب أن نستعملها مرة أخرى. هذا استعمالاتها محدودة. Flaming. This is method of passing the article over a benzene flame, but not heating it to redness. The articles such as scalpels, mouth of test tube, flash, glass slide, and cover slip are passed through the flame a few times, even though most vegetative cells are killed. There is no guarantee that spores too will die on such short exposure. This method too is limited to those articles that can be exposed to flame. Breaking of the glassware may occur. حقيقة نستعمل الفليم هو أنه متى تصل إلى درجة حرارة إلى أن تكون redness. هذه في حالة المواد التي تنعدم direct red of this sterilization. ولكن بها مشاكل هواي لأنه غير مؤمنة أن تقتل السبورات وكذلك احتمال أن تنكسر بعد passing over the flame. Incineration. This method of destroying contaminated material by burning them in incinerator. The articles such as solid dressing, animal carcasses, pathological material and bedding, etc., should be subjected to incineration. This technique results in loss of articles, hence is suitable only for those articles that have to be disposed. The burning of polystyrene material emits dense smoke and hence they should not be incinerated. هذه المواد التي تستعملها هي for waste incineration العمود ليكون not have an infected material when become wasted. The sterilization by hot air. We have hot air oven. This method was introduced by Louis Pasteur. The articles to be sterilized are exposed to high temperature as 160 degree centigrade for duration of 1 hour and electrically heated oven. هذه الأفران الكهربائية هو استعمالها في الهوت air sterilizer. Since air is poor conductor of heat, even distribution of heat throughout the chamber is achieved by fan. The heat is transferred to the article by radiation, conduction, and convection. The oven should be filled with thermostatic control, temperature indicator, mesh shelves, and must have adequate insulation. حقيقة يجب استعمال الفان لتوزيع الهواء من خلال الأوفن لأن الهواء لا ينتقل بشكل متوازي لكل أجزاء الأوفن فهذه الأدوات لا تتعقم ولكن يجب أن نستعمل الفان. The article sterilized metallic instruments like forceps, scalpels, scissors, glasswares such as battery dishes, peptides, flash, flask, oil glass syringe, swab, oils, gases, petroleum jelly, and some pharmaceutical products that can be sterilized by the hot air oven. The process of sterilization. The article to be sterilized must be perfectly dry before placing them inside to avoid leakage. حقيقة يجب أن تغسل الإنسترومنت كلها وتجفف قبل أن نضعها في الهوت air sterilizer. The article must be placed at sufficient distance so as to allow free circulation of air in between. يجب أن توضع الإنسترومنت بمسافات بحيث من خلالها يمر الهوت air. The mouth of flask, test tube, and both ends of pipe must be bulged with cotton wool. The articles such as battery dishes and peptide may be arranged inside metal consister and then placed. Individual glass article must be wrapped in craft paper or aluminum foil before used in a sterilizer. The sterilization cycle. This takes into consideration the time taken for articles to reach the sterilizing temperatures, the maintenance of sterilizing temperature for a defined period, holding time, and the time taken for the article to cool down. Different temperature and time relations for holding time are 60 minutes at 160 degrees centigrade, 40 minutes at 170 degrees centigrade, and 20 minutes at 180 degrees centigrade. Increasing temperature by 10 degrees, shortening the sterilizing time by 50%. حقيقة كل ما نرفع درجة الحرارة 10 كل ما الوقت يقل إلى النصف. The hot air oven must not be opened until temperature inside has fell below 60 degrees centigrade to prevent breakage of glassware. يجب أن لا يفتح الهوت اير أو تخرج المواد قبل أن تنخفض درجة الحرارة إلى أقل من 60 درجة مئوية. The advantage of hot air oven. First, it is an effective method of sterilization of heat-stable articles. Second, the articles remain dry after sterilization. Third, this is only method of sterilization oil and powder. حقيقة الهوت اير اوفن هو الطريقة الوحيدة لتعقيم الاويل and the powders. Disadvantage of hot air oven. Since air is poor conductor of heat, hot air has poor penetration. The cotton wool and paper may get slightly charred. Glasses may become smoky. Take longer time compared to autoclave. هذه هي disadvantage of a hot air oven. Other method of dry heat, infrared rays. Infrared rays bring about sterilization by generation of heat. The articles to be sterilized are placed in moving conveyors built and passed through a tunnel that is heated by infraradiation to a temperature of 180 degrees centigrade. The articles are exposed to that temperature for a period of 7.5 minutes. The articles sterilized, including metallic instruments and glassware. It's mainly used in a central sterile supply department. It requires special equipment, hence is not applicable in diagnostic laboratory. Efficiency can be checked using the brown tube number 4, blue spots. We finished by dry heat. Now go to other sterilization type of heat, sterilization by moist heat. We divided to 3 categories: at temperature below 100 degree, temperature at 100 degree, and temperature above 100 degree. So we start with a temperature below 100 degree centigrade. The first method is pasteurization. This process was originally employed by Louis Pasteur. Currently, this procedure is employed in food and dry industry. The methods of pasteurization are: first, the Holder method, heated at 63 degrees centigrade for 30 minutes. Flash method, heated at 72 degrees centigrade for 50 seconds, followed by quick cooling to 30 degrees centigrade. Ultra high temperature, 140 degrees centigrade for 15 seconds, and 149 degrees centigrade for 0 seconds. This method is suitable for destroy most milk-borne pathogens like Salmonella, Mycobacteria, Streptococcus, Staphylococci, and Brucella. However, Coxiella may survive pasteurization. Efficiency is tested by phosphates test and methylene blue test. Other method is vaccine bath. The contaminated bacteria is in a vaccine preparation can be inactivated by heating and water bath at 60 degrees centigrade for 1 hour. Only vegetative bacteria are killed and spores survive. Serum bath. The contaminated bacteria in a serum preparation can be inactivated by heating and water bath at 56 degrees centigrade for 1 hour or several successive days. Protein in serum will coagulate at high temperature. Only vegetative bacteria are killed and spores survive. Enspirization. This is technique to solidify as well as disinfecting eggs and serum containing media. The medium containing serum or egg are placed in slope of an inspirator and heated at 18 to 85 degrees centigrade for 30 minutes on 3 successive days. On the first day, the vegetative bacteria would die, and those spores that germinated by the next day are then killed the following day. The process depends on the germination of the spores in between inspiration. If the spore failed to germinate, then this technique cannot be considered sterilized. Now, the moist heat at temperature at 100 degrees, that means boiling. The boiling at 100 degrees for 30 minutes is done in a water bath. Boiling water, 100 degrees centigrade, kills most vegetative bacteria and virus immediately. Certain bacterial toxins such as staphylococcal enterotoxin are also heat resistant. Some bacterial spores are resistant to boiling and survive. Hence, this is not as susceptible for sterilization. The cooling activity can be enhanced by addition of 2% sodium bicarbonate. When absolute sterilization is not required, certain material, article, and glassware can be disinfected by placing them in a boiling water for 10 to 20 minutes. The lid of the boiler must not be opened during the period. Syringe, rubber goods, and surgical instruments may be sterilized by this method. Steaming. The steaming at 100 degrees centigrade is more effective than dry heat. At the same temperature as bacteria are more susceptible to moist heat. Steam has more penetrating power. Steam has more sterilizing power as more heat is given up during condensation. Steam sterilizer, it works at 100 degrees centigrade under normal atmospheric pressure. Example, without extra pressure. It is ideally suitable for sterilizing media which may be damaged at a temperature higher than 100 degrees centigrade. It is a metallic vessel having two perforated diaphragm shells, one above boiling water and the other about 4 above the floor. The water is boiled by electricity, gas, or stove. Steam passes up. There is a small opening on the roof of the instrument for escape of the steam. We have either single exposure or tandalization. Single exposure for 1.5 hours is lead to disinfection. Tandalization after John Tyndall or fractional sterilization or intermittent sterilization. حقيقة أول ما استخدم هالطريقة هو تندل فلهذا سميت tandalization. Other name fractional sterilization or intermittent sterilization. The heat label media like those containing sugar, milk, gelatin can be sterilized by this method. Steaming at 100 degrees centigrade is done in steam sterilizer for 20 minutes followed by incubation at 37 degrees centigrade overnight. This procedure is repeated for another 2 successive days. That steaming is done for 3 successive days. Spores, if any, germinated to vegetative bacteria during incubation and are destroyed during steaming. On second and third day, it leads to sterilization. The success of process depends on the germination of spores. The last method of moist sterilization is a temperature above 100 degrees, and the best example is autoclave. The autoclaving is one of the most common methods of sterilization. The principle of the autoclave is in this method sterilization is done by steam under pressure. Steaming at temperature higher than 100 degrees is used in autoclaving. The temperature of boiling depends on the surrounding atmospheric pressure. A higher temperature of steaming is obtained by employing a higher pressure. When the autoclave is closed and made airtight and water starting boiling, the inside pressure increases and now the water boils above 100 degrees centigrade. At 15 pounds per square inch, pressure 121 degrees centigrade pressure is obtained. This is kept for 15 minutes for sterilization to kill spores. It works like a pressure cooker to destroy the infective agent associated with spongiform encephalopathies, bronchs, higher temperature or longer time use, like 135 degrees centigrade or 121 degrees centigrade for at least 1 hour as recommended. حقيقة الأوتوكليف مثل قدر الضغط. قدر الضغط هو سموه pressure cooker for doing food faster. ليش؟ لأن زيادة الضغط راح درجة الحرارة الغليات تزداد من 100 مئوية إلى تصل إلى 121 أو 135 درجة مئوية. Advantage of the autoclave. It has more ventilative power than dry air. It moistens the pores. Moisture is essential for coagulation of protein. Condensation of steam on cooler surface releases latent heat. Condensation of steam draws in fresh steams. The disadvantage of autoclave. Drenching and wetting or article may occur. Trapped air may reduce the efficiency. Take long time to cool. Sterilization control. We have physical methods including automatic process control and thermocouple and temperature chart record. This is the main disadvantage of autoclave. The autoclaving is highly efficient because when steam condenses on article, it liberates latent heat to the article to be sterilized. High penetrating power of the steam under pressure. Non-toxic, no time consuming. Type of autoclave. We have two types of autoclave. First one, simple pressure cooker type, laboratory autoclave. The second one, steam injected downward displacement, laboratory autoclave, and high pressure vacuum autoclave. The autoclave is a metallic cylinder vessel, vertical or horizontal cylindrical body, perforated tray to keep the article on the lid. There are as part of the autoclave, first a screw clamp and a gauge for indicator pressure, a safety valve which can be set to low off at any desired pressure, stop cock to release the pressure, a discharge tab that for discharge the water. This figure shows the parts of the autoclave. Working of autoclave. How can you use the autoclave? First, place material inside the article to be sterilized must not be tightly packed. The screw cap and cotton plug must be closely fitted. Second, close the lid. Leave stop cock open. Third, set the safety valve at the desired pressure. And fourth, heat the autoclave. Air is forced out and eventually steam ensures out through the tap. Fifth, close the tap. The inside pressure now rises until it reaches the set level, example 15 pound, when the safety valve opens and excessive steam escapes. Keep it for 15 minutes holding time. Stop heating. Cool the autoclave below 100 degrees centigrade. Open the stopcock slowly to allow air to enter the autoclave. For what purpose use autoclave? Autoclave is used for sterilization of surgical instrument and dressing, bed lining, cotton gauze, and culture. We have steam inject autoclave, the double-walled chamber in which steam at 121 degree is introduced from an external source. Steam enters the jacket from which it enters the chamber, migrating downwards, replacing the air which is expelled through a discharge tap at the bottom. Flash autoclave is sterilized at 134 degree for 3 to 5 minutes. Used in operation room in emergency situation. هذه الفلاش هو يستعمل صالات العمليات الطوارئ لسرعة sterilization وسرعة استعمال الانسترومنت. There are certain precautions taken when using sterilization of autoclave. The article should not be tightly packed. The autoclave must not be overloaded. Air discharge must be complete, and 3 should not be any residual air trapped inside. Caps of bottles and flash should not be tightened. Autoclave must not be opened until the pressure has fallen or so the content will boil over. Article must be wrapped in paper to prevent drenching. Bottles must not be overfilled. The other type of sterilization, other than heat, the sterilization by radiation. We have two types of radiation are used, either ionizing or non-ionizing. The ionizing radiation are high energy ray with good penetrative power. Non-ionizing low energy ray with poor penetrative power. The non-ionizing radiation ray of wavelength longer than visible light are non-ionizing microbiocidal wavelength of ultraviolet ray lie in the range of 200 to 280 nanometer, with 260 nanometer being most effective. The disadvantages of using ultraviolet ray include low penetrative power, limited life of the ultraviolet bulb. Some bacteria have DNA repair enzymes that can overcome damage caused by ultraviolet ray. Organic matter and dust prevent its reach. Rays are harmful to the skin and eye. It does not penetrate glass, paper, or plastic material. This is the silent killer of sterilization of ultraviolet disinfective system validity. The ionizing ray. The electron beam are particulate in nature while gamma rays are electromagnetic in nature. The high-speed electrons are produced by ion accelerator from a heated cathode. Electron beams are employed to sterilize articles like syringe, gloves, dressing packs, food, and pharmaceutical materials. The sterilization is accomplished in a few seconds. The disadvantage of using ionizing radiation, poor penetrative power, requirement of sophisticated equipment. A third method of sterilization, sterilization by filtration. The filtration does not kill microbes, it separates them out. Membrane filter with pore size between 0.2 to 0.545 micrometer are commonly used to remove particles from solid solution that can be autoclaved. It is used to remove microbes from heat-labile liquids such as serum, antibiotic solution, sugar solution, urea solution. Various applications of filtration include removing bacteria from ingredients of culture media, preparing suspension of virus and fags free of bacteria, measuring size of virus, separating toxin from culture filters, counting bacteria, clarifying fluid, and verifying hydrated fluid. Filtration is aided by using either positive or negative pressure using vacuum pump. The older filters made of earth winds or asbestos are called bad depth filters. Different types of filters are first, earth winds filter, asbestos filter, centered glass filter, membrane filter, and lastly air filters. This method is a filtration by earth winds filters, and we can see how filtrate the water by this method. The use of asbestos material for asbestos filtration of air, mainly in air conditioner. The sanitary glass filter that used for any fluid that have filtration in lab. The membrane filter by use a membrane to filter the air through it. The air filter that used for theater room or that any room have filtrate the air that enter to it. Other method of sterilization or disinfectant is sonic and ultrasonic vibration. Sound wave of frequency less than 20,000 cycles per second kill bacteria and some virus on exposing for 1 hour. Microwaves are not particularly antimicrobial in themselves. Rather, the killing effect of microwaves are largely due to heat that they generate. High-frequency sound waves disrupt cells. They are used to kill and disinfect instruments as well as to reduce microbial loads. This method is not reliable since many viruses and fungus are not affected by these waves. thank you for your listening this lecture and continue the chemical sterilization in second lecture.